You should still be copying this down. Thank you. So, we had projectiles, I'm going to say last year, but for some of you guys it was a couple weeks ago. But they only went one way, straight up and straight back down. Now we're going two ways. That's 1D. Now we got 2D. So this guy, I know it's a big looking arrow, but all that says is that's the initial velocity. So that's not what it is like up here in the air. That's what it is right there. Okay? But because we want to break this vector down into its x and y, I want to make it nice and big. Make sense? That's the initial velocity. This thing, whatever it is, baseball, an arrow, a rocket, a little tiny pebble, has an initial velocity of 20 meters a second, but now it's not straight up. It's at some angle. And what angle is that? 30 degrees. Have we seen this one before? Yeah. Yeah, because you already wrote it down. So Vy is what? Quickly. Good. Oh, I didn't mean that quick. Awesome. How did he get that? He went 20 times sine 30. Or did you just memorize that from before? You should know, you guys are in grade 12, you've all done math 11. You should know sine 30 is a half. What's half of 20? Yeah, okay? But if you don't, well, that's a quick little operation on your calculator. What is cosine 30, Jake?
Oh, grade 3 ever too. So
good. Anyone else know that? Did I say you should kind of memorize? Oh, someone else did math 12 already in here too, yeah. You should have that memorized. I said you should in grade 11. It'll make it that much easier in math 12. How many of you did? Anyway, that's 20 cosine 30. And I'm a smart boy, so I know cosine of 30 is root 3 divided by 2 times 20. That's 17.3 meters a second. I'm just going to skip the units, but we know it's meters a second. Okay? Question. How far does this projectile travel in the horizontal direction? Well, remember the first formula we gave you in kinematics in physics 11? If you move at a constant speed for some time, you can probably figure out the distance, right? Is this thing moving at a constant speed in the x direction? It is. You have to completely separate what's happening vertically to what's happening horizontally. Okay? They're separate events. They're independent of one another. This thing will continue to go at 17.3 meters a second in that direction for as long as what? Until it hits the ground, right? I don't care what it's doing up and down. We know it goes up and it probably comes down unless I threw this thing really, really fast. But, you know, gravity being what it is on this planet, this is probably strong enough for this thing. That's not that fast. It's probably going to be coming back down. Okay, but vertically, I don't care. This happens. This is constant. Until it hits the ground, it's doing that speed. So all I need to know to answer this question is, how long? What's the time? How do I find out the time? By analyzing what's going on vertically, because that's the determining factor on when it hits the ground. How strong gravity is going to suck it back down to Earth. Because you know the time's going to be different on the moon. It's going to be different on Jupiter, right? Time's going to be a lot smaller on Jupiter. Okay? On Earth, it's going to be like this. On the moon, not as strong gravity. It's going to take a lot longer to hit the ground. So, now we're back to just analyzing it up and down. This is what we did last year, Physics 11. What do I know? Well, initially, vertically, that's Vy. What is its initial speed vertically? Okay, so forget about horizontal for the minute. Vertically, this thing starts here, it goes up to the top, and then it comes back down and hits Earth. It happens to be doing this at the same time, but ignore that part. All I want to think about is vertically. Vi or Vo, what's the initial speed vertically? That's what this is. 10 meters a second. What else do I know? How am I going to solve this? And again, it hits some maximum and comes back down, right? So I need to know other pieces of the puzzle. Do I know this? Yeah, it's on Earth. We assume it is. If this is up, and I'm taking that as positive, I know that's this way. That's got to be negative, okay? So make sure you have a minus there. What else do I know? When I put VF, there's two ways to think about it. Now this is just vertically, but I'm going to put a little horizontal in there to show you what happens. When I put VF, is this the VF I want? Well, if it goes up at 10 meters a second, I know it hits the ground at negative 10 meters a second. So that might be a way to do it. But probably what's easier, and what I taught you is, let's just do half of the time and then double it, because I know this thing's symmetrical. At the top, what's the speed? 0. Okay? So I'm going to get half of this motion, take a time, and then I'm going to double it. What's a formula given VOA, VF, and T to solve for T? Does that one work? All right. VF is 0. VO is 10. A is negative 9.8. Okay, let's put the plus in there. Solve that thing for T. Minus 10 to both sides. Divide by negative 9.8. And the time, just to get to the top, is going to be just over a second. What did I get? Yeah, don't round this yet. Okay? That's just to get to the top. So, but because I'm doing this, I need to know when it hits the ground, not just when it's at the top. Half the distance is 1.02. This is symmetrical. It also takes 1.02 to get from the top down. So the total time for this flight is 2.04 seconds. Okay, that's when it hits the ground. So how far does it go in the horizontal direction? Well, here's my good old formula. V is d over t. To use the triangle thing, feel free. I want a distance. That's velocity times time. And what velocity do I want now? I want that one. Because when this thing hits the ground vertically, that's when it hits the ground horizontally. I know it goes at 17.3 meters a second times 2.04 seconds. So that will give me the answer, 35.3 meters. That's how far it went horizontally. Okay? So I think I'll just do that for now. The next part of this question, if you see some really hard questions in here, will be, I'll save this for Monday, okay? Now it hits a wall. How high up on the wall does it hit? Okay? Taking the exact same thing to the next level. Isolate what happens vertically from what happens horizontally. But let's just put a hold on that for now.